All right, we're going on now to section 5 of chapter 5, where we are dealing with equations. Again, they're in standard form, but now the letter A does not equal 1. And you might say, well, what's the difference? Well, if A is 1, then when we set up our first terms here, it's just going to be an X and an X. But now let's say if X is, or the A is 6, then it might be a 6 and a 1, or a 2 and a 3, or a 3 and a 2. So that tends to complicate what you're going to get then for your other terms, and it requires, I should say, a lot more looking at what you're doing. So let's get started and check it out. Now, the first method that we're going to show you actually two methods. One is the typical unfoiling the foil, which we call factoring. Another method that we'll be using toward the second part of this is called the AC method, where we take the A and the C of our quadratic equation, and I will show you that in some detail. So as we look at this example, this is very typical of what we're going to be doing. Notice our A term is a 3. 3 is a good one, by the way, to start with. Is it in standard form? Yes. Can we factor out any common factor? No. So the next thing we do, put two sets of parentheses, just like we did before. Now, since 3 is prime, then we're going to put a 3x there and an x there. So we don't have to think about whether it's going to be other numbers. Since it's prime, there's only the one set. Now 5 is also prime. So where do we put the 5? Do we put the 5 here, or do we put the 5 here? And again, you're brainstorming and you're using art in the form of creative thinking. And as I put the 5 there, that's not going to end up as a 14. But if I put the 5 there, that's going to be a good spot for it, and a 1 there. Because now what I'm mentally thinking, as I do my outers, I get a 15x. As I do my inners, I get a 1x. And I want my middle term to be a negative 14. Well, in order for that to happen, this would have to be a negative, and this would have to be a plus. So, what is my sign then to get a negative 15 for my outers? Well, a negative 5 there. And to get a positive 1 for my inners, I put the plus there. And now what do? I foil it, and it checks. All right, so they started us with a very easy one, but throughout these, we're going to use this concept of guess and check. Guess and check. Another phrase, trial and error. If you're wrong, you try something else. Okay. and they're just going through it. You'll find a lot of this in your textbook. And if you're reading your textbook, that is also a good source of information. And they're just showing you the guess and check part of this. Okay. Now, as we look at this one, is it in standard form? Yes. Is there any common factor you can take out of this? And yes. So I'm going to pause to set it up for you. So I knew I could take something out. I wasn't sure what it could be. Now I could take a 2 out of there and a 2 out of there, but not out of there. So I used the rule of threes. This is a 9. I could take a 3 out of there. This is a 5, 6. I could take a 3 out of there. And this is 6. I could take a 3 out of there. And I could take an x out of each term. So I take out a 3x. When I do, I get this. So this is my new trinomial that I have to factor. And let's just do some guess and checks down here too. And again, you're doing this in pencil. So if you have to trial and error, if you get an error, you're going to have to do some erasing. So I have a 6x squared there. And what factors do I have? Well, I could have a 6x and an x, or it could be a 3x and a 2x. This is what I showed a little bit on the initial slide. So, which do I do? Well, let's suppose I have that one. Now I have here an 8. And this is where it gets challenging. Now I could put an 8 here and a 1 there. And then notice I have a 47. Yeah, this is going to be the one right here. Now, if this didn't work, I'd have to try this, because I know now as I do my outers, 6 times 8 is 48. And there's a 1. Now I need a negative for this. So this is going to be 8 here, a 1 there, and this is going to be a 6x and an x. Now I need a negative 48 in order for this to work out. So this will be negative and this will be positive. And if I FOIL now, I get a 6x squared. My outers are a negative 48x. My inners a positive 1x. And my last a negative 8. So this checks out. Now again, I didn't know beforehand going into it which of these would be my start. Often it's not the 6 and a 1. But because this middle term was so big, I thought it was a very good possibility. Okay. So they're factoring out. And then they're showing you what I showed, the possibilities. And then you just guess and check until you get what you need. Okay, let's go on. Now here's another one. Step 1, is it in standard form? Nope. So let's put it in standard form. Negative 3x squared plus 14x plus 5. Now, often we do not want to have a negative as our first term. So what I'm going to do, and I'm allowed to do this, is factor out a negative 1. This changes all my signs. This now becomes a positive x squared. This becomes a negative 14x, and this becomes a negative 5. What I did is I just factored out a negative, negative 1, and now I have my a term is positive. Now I still need that outside, and since 3 is prime, that's a good one. And again, my 5 is prime. I think we did one like this here. And this is going to be negative, and this is going to be positive. Now, what we can do, so we don't have to write that negative all the time, is just multiply these two terms by this negative. By the way, I would accept that on a test, but you could write this as a negative 3x and a negative 1. This one doesn't change. And that's the answer. Okay? So the strategy we're illustrating here is put it in standard form, get your a term positive by factoring out a negative 1 that changes all the signs, then factor that, and then you can multiply the negative 1 through these, and you are finished. So that's what they're doing. And they're factoring out the negative 1. And there we have that. And the factorization is that. And you could have put the negative 1 in there. I see they didn't do that. That's okay. So again, here are a series of rules or strategies, and we've pretty much illustrated all of these. If you want to copy them in your notes, or if you read them in your textbook and copied them in your notes, that's fine, or pause the tape. Okay, now we're going to illustrate what is called the AC method. The AC method sets the expression in standard form. Again, the first term, the coefficient of x squared is a, the coefficient of x is b, and the coefficient of c is just itself, c. Now the AC method starts off by multiplying a by c. You multiply these. Again, the first thing you do is factor out any common factor. Then their second step is multiplying a times c. Okay, then you will look for factors of ax, the product AC. Look for factors that will give you your b term. And that's what they're describing here. But I will show you how to do it. If you want to write these down, again, pause the tape. So let's do one. We want to identify our A. Our A is 4. Our B is -5. And our C is -6. So the first thing we're going to do is multiply A times C. That would be 4 times -6. That gives me a -24. Now, our B term we said is -5. Now we're looking for factors of a -24 that add up to a -5. Well, again, I could do a big list and maybe the book will show you a big list, but I know they're going to be an 8 and a 3. Why? Well, 8 times 3 is 24. Now I need a -5 out of that. So in order to get a -5 out of that, the 8 has to be a negative, and the 3 is going to be a positive. Okay? Now, we are going to rewrite this expression, but instead of using 3 terms, we're going to write a 4-term expression, putting this -5 in terms of this. So watch what I do. Let's see if I get my pen working here. Okay, 4x squared. That doesn't change. I'm now going to write a -8x and a positive 3x, and then I just put my C term, a -6. Now notice what I've done. I've taken a 3-term expression, put it into an equivalent 4-term expression, having multiplied the A times C, get a -24, looking for factors of a -24 that will add up to a -5. Okay? And then rewritten that, putting that -5 in the form of a -8 and a 3, a positive 3. This is -5. But now I have a 4-term expression. And how do we factor a 4-term expression? And we factor it through grouping. So we're going to group these 2 terms and these 2 terms and factor it like we did earlier in chapter 5. Now I can take a 4x out of here, and I'm left with an x minus 2 out of these first 2 terms. Now I want to have in my second little set here an x minus 2. Well, what do I take out of these to get that? And the answer is a positive 3. You might remember this. We did some of these. So now, what do? Well, I put 2 sets of parentheses. I put my x minus 2 in one, and then I bring my 4x from there and my plus 3 from there, and I have factored this using the AC method. And I FOIL this and it checks. Now, could you have gone from this on the top initially into this? And I believe the answer is yes. This is not a difficult one, but it illustrated the AC method. Now, when you get some that you can't do the traditional factoring way, you might try the AC way. Now, notice this is kind of teasing apart that middle term, but here you get to know what you're going to put there, because this could have been a 2 and a 2, a 3 and a 2, a 3 and a lot of different combinations. So this is a very useful method, but it takes practice to master it. And they're just taking you through the steps. Look at all these possibilities here. You see we had a little phone call coming in, but we took care of business, and look at this. Wow. And you're looking for one, this set right here, that gives you that -5. But a lot of brainstorming and artistic work of creativity figuring out all that stuff. Now, once you get to an answer, of course, that's where you stop, and we do some of that mentally. And there we end up with what we had. Now notice they're putting this common factor out front. I tend to put it over here, bring these, but it's the same. And you check it by foiling, and it works out. Okay, let's do this one now using the techniques we just had. And step 1, is there a common factor? Yes, we can factor out from each term a 2x. So this gives me then a 4x squared plus 5x minus 6. And now we're going to use the AC method. A times C is a -24. And this one actually looks a little easy because we already did it, except this sign is now positive. So the factors that are going to give us a 5 in the middle would be 8 and 3. But this time we need a +8 and a -3. So now we're going to rewrite this, and we have to do it. We have to keep in mind our 2x out there. We can't lose that. So we're going to get a 4x squared plus 8x minus our 3x minus 6. So out of our first two terms, we're going to factor out a 4x. Now here we need an x plus 2, and we have a negative and a negative. So we're going to factor out a -3, and that reverses the signs, and we get what we're looking for. So now we're going to get a 2x out there, and I really don't need the brackets anymore. And I tend to put this over here, and then the 4x minus 3. And again, if I FOIL through this, I get well, it would be this, I would get this up here. Foiling this gives me this up here. And then I just multiply through by a 2x, and it brings me back, and it checks out. Again, this is the AC method. Get our product of AC, and then we want factors of that will add up to our B term, which is a positive 5. Then we rewrite it. This is positive 5x. And in a way, this is closely related to, the traditional way of doing this. And then grouping like terms to get this up here. And it gets to be a little tedious, but not too bad. So there's where we redid our 3-term expression into a 4-term expression. Now noticing they're doing it a little bit differently than I did, which is okay, it works out either way. And this is our answer. And of course we needed to have the original 2x there. Okay, now when we are going into equations now, and our A term is not a 1, it's the exact same thing as we use the principles of the zero products. So let's do one. Wow, that's okay. Is it in standard form? Yes. What do we do first? We factor out the greatest common factor, which here is going to be x to the 3rd. Which leaves us with 2x squared minus 7x plus 3. Now I could use the AC method, but I'm going to be risky and try it right like this. Okay, I know this is going to be a 2x because 2 is prime. And this is prime also, and I want to get a 7, so this was sort of an easy one. Now, what will my signs be? Remember, this is a positive 3. This is a negative 7. In order to get there, I have to have 2 like signs. In this case, to be sure it becomes a negative, I need a negative times a negative to make this a positive, and this checks out. Okay, now the next step is equate each of your factors to 0. Now note that this equation was to the 5th degree here. So in a sense, I need 3 answers. Well, x to the 3rd, I'm going to use the 0 3 times. So that gives me 3 answers there. And then here, I'm going to solve this. 2x equals 1. Transpose that. So x equals 1/2. And this is going to be x equals 3. So my 3 answers are, 3 of them are zeros. Usually you don't have to write them 3 times if it's all the same. And this is a positive 1/2. and this is a positive 3. Now if you put x is 0 in there, that's 3 times, that works. If you put x is 1/2, that you're going to raise to the 5th power, theoretically that's going to work too. And so does this one. So let's take a look. Okay, they did what I did, factored out an x to the 3rd, and then solve these, and that's what we got. Again, if the answer is repeated, you don't have to write it 3 times. And those are your solutions. All right, now they're winding this up here a little bit in terms of defining the domain of something. And here we're looking for what values could X have as a domain representative. Well, all we do to do that is it's in our denominator. First of all, if there's only numerators, the domain is all real numbers. So from negative infinity to positive infinity. But since we have a denominator that has x in it, we have to find those values of x that make the denominator a 0. So we just do it like so. We don't care about the numerator anymore. It's just the denominator. So we factor the denominator, and they usually give you something that's easy to factor. And this will be a plus, and this will be a minus. So here x is going to equal a 2, and here x is going to equal a negative 4. But they want to know what values of x can you have in the denominator. And what these indicate is that if x were a 2, that would make the denominator a 0. If x were a negative 4, that would make the denominator a 0. So these are values that are excluded from the domain of x. That you would write this in a set builder notation. You would say that x is a real number, but x cannot be a 2, or x cannot be a negative 4. We exclude these values because that would make the denominator a 0. Okay, I probably should have looked at what they had here. Okay, that's what they're saying. They're going to exclude any values of x that make the denominator a 0. So you put the denominator equal to 0, you factor it, and these are the values that you will exclude. Oh, good. I had it right. All right, that winds us up.